I'm Anil Kumar. Welcome to my series on reading information from the graphs. We're trying to analyze speed time graphs, or you can say velocity time graphs. To give you the background, acceleration you can read from speed time graph as gradient or slope at any point, and distance traveled is the area under the speed time graph. So here the question is based on the figure given to you. So we have shown velocity and time, velocity in meters per second, time in seconds. Based on this, we have three questions. You can always pause the video, answer these questions, and then look into my suggestions. The very first one is find acceleration at t equals to 7 seconds. B is find total distance traveled in first 8 seconds. And C is find average velocity for the whole journey. So let's see how to answer them one by one. So part A is to calculate the acceleration. So acceleration is rate of change, correct? So acceleration at t equals to 7 seconds. So at t equals to 7, from the graph, we can see that the point is right there. Now the slope at this point is, you can do rise over run, correct, to find the slope. So acceleration basically is rate of change. So we could do this difference of v values. So on this scale, we can use the point. This is 20, 30. So each is going by 5 units. So this is 35, correct? So 35 over this is 15. So using these points, we get this as 35 minus 15, and this is in meters per second, over the time difference, which is 8 minus 6, right? So 8 minus 6 in seconds, right? So we get meters per second square as our units. So that becomes 20 over 2, right? 20 over 2, which is 10 meters per second square. So that becomes our answer for part A. Clear? B. We need to find total distance. Now total distance is area. So to find area, we could divide this into 3 portions, right? So rather you could do 3 or 4. You could use area of a trapezoid, or we could do like this. Right. So let's do it in 4 portions. So we'll find area of each unit. So area of 1, area of 2. You can use this trapezoid as such and then find the area, or you can say, well, A3 and A4. No harm, right? So let's find the area. So area of portion 1, which is triangle, will be half of, base is 3 units, so half of 3, and the height is 15, right? So half of 3 times 15 plus. This is a rectangle which is from 3 to 6, so it is 1, 2, 3 units wide, and here it is 15 units in velocity, right? So it is 3 times 15 plus, we could have this as a rectangle again, 2 by 15, right? So 2 times 15, and then we will add the area of the triangle, which is half of, base is 2 units, and the height is from here to there, we calculate this to be 20, right? Times 20, correct? So let's figure this out. So, okay. Some simplifications. Okay, so we have 45 over 2. Let's write down 45 over 2 plus this is 45. That one is 2 cancels. Sorry, this is 2 times 15, which is 30. Here these 2 cancels, we have 20 plus 20, right? So these are the 4 areas. We can combine them and write down our answer. So it is 20 and 30 is 50 plus 40 is 95, and this is, okay, uh, 22.5, right? So let's do like this. 22.5 plus 50 and 40, 95. Okay. 95 is okay. So that gives you 0.5, 5 and 2 is 7, 9 and 2 is 11, correct? Distance meters. So we get our answer as 117.5 meters. C. We need to find average velocity for the whole journey. Now average velocity is ratio of distance over time, correct? So in this case, the total distance was measured as 117.5, and we'll divide this by the time taken, which is 8, correct? So we can get the velocity. So 8 times 1 is 18, 8, and then we get 337. So 8 times 4 is 32, and that gives you 55. 8 times 7 is 57, so we can say approximately 14.7 meters per second. Is that clear to you? So that is how we could round it and write approximate answer in meters per second, correct? So I hope these steps are absolutely clear. Rate of change is the acceleration, distance is the area under the curve, and average velocity is total distance over total time. Feel free to write a comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.